Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is the count the elements with the maximum frequency. So here we are given a nums array which consists of positive integers, and then we need to return the total frequencies of the elements in the nums such that those elements all have the maximum frequency, and the frequency of the element is number of occurrences of that element in the array. So here we are given an array, and then we need to find all the frequencies of the elements with the maximum frequency. So, and then one more thing is the constraint states that the nums are in the length of 1 to 100, and then it ranges from 1 to 100. The value of the nums will be from 1 to 100. So let us see how can we solve this problem. Let's take this particular example. Suppose let's say we have 1, 2, 2 and then 3 and then 4, 1 and then 4. So we need to store the frequencies of the elements which are present in this particular number in this particular array. So we'll 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 see the element which is present in the array, and then we'll increment the index of that particular frequency. So here we'll take frequency of all the elements, which will be like 100, and then for this particular 100 we will try to increment whenever we find some particular number. Suppose let's take this particular example, and then this will be like indexes of the frequency array, and then for this particular case we are going to increment 1. Why? Because it is 1, and then again at this place 2 is present, so we'll try to increment to 1. Initially all the indexes elements will be 0 for this frequency, and then whenever we come here to 2, we'll increment to 2. Why? Because here the number of elements present here is 2, so we'll try to increment 2, and then again we'll see 3, so we'll increment to 1, and then again 1, so here it becomes 2, and then again for the 4 here it becomes 1. For this particular example the maximum frequency is 2, and then the the frequencies of the elements which contain the maximum frequency is 2 for this particular number, and then for this particular number it is 2. So to return this particular uh, answer, we need to traverse all the elements which are present in the array, and then we'll increment the frequency. And then one more thing is, suppose let's say we want to find the maximum frequency, we need to try again traversing all the elements which are present in this frequency, and then we'll check whether this frequency is equal to 2. If it is equal to 2, then we are going to increment to frequency, and then we'll move to the next frequency index. So this will be like uh, twice the traversal. That means we'll increment the frequency for once, and then we'll do the frequency, and then again we'll check the frequency array, and then we'll compare with the maximum frequency, and then we'll return. So instead of doing that, can we solve this in better approach via one traversal? Let us see. So here whenever we were writing here whenever we were writing the frequency, this frequency, can we do this in one traversal? For this particular 0, it contains like 0, so the frequency is 0, and then whenever we have maximum frequency, which is this, till here the maximum frequency is 1. Now the maximum frequency becomes 2. That means we need to figure out a way so that we'll store the maximum frequency. So the maximum frequency can be stored with the maximum frequency equal to maximum of particular frequency element after incrementing, and then the previous maximum frequency. So that will be 2. And then one more thing we need to store is number of elements which have that particular maximum frequency. So for this, till now it is 1, and then when it comes to here it becomes 2. Why? Because here the maximum frequency of this element, maximum frequency and then frequency of this elements matches. So we'll try to increment the number of elements which have the maximum frequency, and then whenever we move from 1 to 2, then we are going to say the frequency is greater than the maximum frequency. So we will try to make the frequency as 1, and then again we'll move to the next element. So let's see the code for this. So this will be one traversal. Instead of doing twice, we are going to do only once. So the frequency will store the frequency of all the elements which are present, and then this will store the maximum frequency in the array, and then this will contain all the number of elements, the number of times the maximum frequency elements are present. So suppose let's say we'll increment the frequency, and then number of times will be added when frequency of this particular element and then maximum frequency matches. That means we are going to say the number of elements with this particular maximum frequency is increased. Suppose let's say the frequency is frequency of this number is greater than the maximum frequency, then we can say that number of times will be 1. Why? Because this is the time where the frequency is greater than maximum frequency. That means maximum frequency becomes frequency of now. So we'll be doing number of times equal to 1, and then maximum frequency equal to frequency of now. At last we are going to say number of times number of elements as a maximum frequency, and then whatever the maximum frequency. So we are going to return this. Yeah, for this particular case, if we go through the time and space complexity, the time complexity is big of n, and then the space complexity is also going to be big of n. Why? Because we are taking the range of this range of this now. Yeah, that's all for this video. Thanks for watching the video.